Hi all, welcome to new class. Today's class is the problems related to signal flow graph. That is the problems to find the overall transfer function from the signal flow graph. Let us do some problems. First one, find the overall transfer function of the system whose signal flow graph is shown in the figure. So this is the given figure. So to find the overall transfer function, we have Mason's gain formula. Mason's gain formula transfer function is equal to 1 by delta sigma k pk delta k. So here k is the number of forward paths. So first of all find the number of forward paths. So this is one forward path. And what do you mean by forward path? It is a path from an input node to output node that does not cross any node more than once. So this is one forward path, and there is one another forward path, that is this one. So this is another forward path, that is the first one is 1 2 3 4 5 6 7 8. These are the first forward paths nodes, and second forward paths nodes are 1 2 then 5 6 7 8. So there are two forward paths. Next step is to find forward path gain, that is pk. So for the first forward path, the gain is the product of the branch admittances or gains of a forward path is the forward path gain. That is, for the first forward path, the gain is 1 into G1 into G2 into G3, G4, G5 into 1. So, first forward path gain is G1, G2, G3, G4, G5. And second forward path gain is G6, G4, G5. That is P1 equal to G1, G2, G3, G4, G5, and P2 is equal to G4, G5, G6. Next we have to find the individual loop gains. So for that find the individual loops. So individual loop, what is individual loop? So individual loop is a closed path starting from a node and after passing through a certain part of a graph arrives at the same node without crossing any node more than once. So here this is one individual loop, that is from here it starts and ends at the same node. So this is one individual loop, and also this is another individual loop, and this is not individual loop, and next is this is the third individual loop. So there are three individual loops here. For the first individual loop, the gain is G2 into minus H1. For the second one, G2, G3 minus H2. For the third one, G5 into minus H3. And let the individual loop gains are P11. So P11 is minus G2 into H1. Second one, P21 minus G2, G3, H2, then P31 for the third individual loop minus G5 into H3. Next we have to find the gain product of two non-touching loops. So first of all we find the individual loops and gains. Then next we have to find the two non-touching loops. So two non-touching loops means this is one loop. So there are three loops, and out of these three loops, this loop and this loop are non-touching. So these two are two non-touching loops. Again this loop and this loop are non-touching. So there are two non-touching loops. So number of two non-touching loops equal to 2. Now we have to find the gain product of the two non-touching loops. So for the first two non-touching loop, the gain product is G2 minus H1, G5 minus H3. And for the second two non-touching loop, the gain product is G2, G3 minus H2 into G5 minus H3. And let the gain product of the first combination of two non-touching loop. Gain product of first combination of two non-touching loops, let it be P1 2. So this 2 is for two non-touching loop. Here this one is for individual loops, and that is equal to, we get these two are the two non-touching loops. So P11 into P31, and that is equal to minus minus cancelled. So we get G2, G5, H1, H3. And gain product of the second combination of the two non-touching loops, let it be P22, and that is P21 into P31. P21 into P31, and that is equal to multiplication of these two, that is G2, G3, G5, H2, H3. Next we have to find the values for delta and delta k, and delta is equal to 1 minus sum of individual loop gains plus sum of gain product of two non-touching loops. And here, is there any three non-touching loops? Only three loops are there, and these two are non-touching, and there is no three non-touching loops here. So here minus sum of gain product of three non-touching loops is 0. So no need to write that. So here 1 minus sum of individual loop gains is this one, that is P11 plus P21 plus P31. Then plus sum of gain product of two non-touching loops, that is P12 plus P22. Now put the values. 1 minus P11 is minus G2 H1, then minus G2 G3 H2, then minus G5 H3, plus P12 is G2 G5 H1 H3, then plus G2 G3 G5 H2 H3, and that is equal to 1. This minus we can take outside, so it will be plus here 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. Now we have to find the values for delta K. That is, we have to find delta 1 and delta 2. And delta 1 equal to. So how will you find delta 1 and delta 2? Delta 1 is delta for that part of the graph which is not touching the first forward path. So this is the first forward path. And what is delta? Delta means 1 minus sum of individual loop gains plus sum of gain product of all possible combinations of two non-touching loops plus etc. So here 1 minus sum of individual loop gains, that is this is the first forward path and sum of individual loop gain. So here we have to find the loop which is not touching the forward path. So there is no loop which is not touching this first forward path. So delta will be equal to 1. That is, delta 1 is 1 minus sum of individual loop gain. So here for the first forward path there is no loops which is not touching this first path. So 1 minus 0, that means 1. Now we have to find delta 2. So delta 2, this is the second forward path, and which loop is not touching the second forward path? This loop does not touch the second forward path. So there is one individual loop gain here. So we have delta 2 is equal to 1 minus this loop gain. That is, delta 2 is equal to 1 minus P11. That is 1 minus G2 H1, and that is equal to 1 plus G2 H1. Now we can find the transfer function T equal to 1 by delta sigma K Pk delta K, and that is equal to 1 by delta, here putting the values for K, we get P1 delta 1 plus P2 delta 2. So all the terms we have already written here. So P1 delta 1 is P1 G1, G2, G3, G4, G5 into 1. Then plus P2 is G4, G5, G6 into delta 2 is 1 plus G2 H1 divided by, and delta is 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. So this is the transfer function. So in this way we can find the overall transfer function very easily. That is, using the Mason's gain formula we can find the overall transfer function very easily. Let us do another problem. Find the overall gain C of S divided by R of S for the signal flow graph. So this is the given signal flow graph. There are 7 nodes. So first step is find the number of forward paths K. So this is one forward path. So only one forward path is there. And find the gain of forward path. That is, let the gain of forward path be P1 equal to the gain product of all the branch gains G1, G2, G3, G4. G1, G2, G3, G4. Next we have to find the individual loops. Individual loop gain we have to find. So this is one individual loop. This is another individual loop, and this is the third individual loop. So there are three individual loops. So let the first individual loop be this one. So the loop gain of the first individual loop be P11, and P11 equal to G3 G4 minus H1, that is minus G3 G4 into H1. Then for the second loop, let the second loop be this one. So P21 equal to G2 G3 minus H2 minus G2 G3 H2. Then the third loop, that is P31 equal to, so this is the third individual loop, and gain product is G1 G2 G3 G4 into minus 1, that is minus G1 G2 G3 G4. Next we have to find the two non-touching loops gain. So the two non-touching loops, so here all the loops are touching, so there are no two non-touching loops. Now we have to find the values for delta, that is delta equal to 1 minus sum of individual loops, that is P11 P21 then plus P31, and here no two non-touching loops. So 1 minus P11 is minus G3 G4 H1 minus G2 G3 H2, then minus G1 G2 G3 G4, and that is equal to 1 plus G3 G4 H1 plus G2 G3 H2 plus G1 G2 G3 G4. Next we have to find the values for delta 1. Since there are only one forward path, only delta 1 is there, and delta 1 is 1 minus delta 1 is the delta for that part of the graph which is not touching the forward path. So only one forward path is there, and there is no part of the graph which is not touching the forward path. So we can write delta 1 is equal to 1. Now by Mason's gain formula, C of S divided by R of S equal to 1 by delta sigma k pk delta k. That is here only one forward path, and we can write P1 delta 1 divided by delta, and that is equal to P1 is G1 G2 G3 G4 into 1 divided by delta is 1 plus G3 G4 H1 plus G2 G3 H2 plus G1 G2 G3 G4. So this is the transfer function C of S divided by R of S. So let us do the more problems related to signal flow graph in the next class. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.